The rest of these are a lot harder because this is pretty straightforward. And so now we're going to talk about all the different ways that these normal distribution problems can get difficult. So here we go. It's going to get difficult. Cliff catches 5 trout in one afternoon. Find the probability that at least 2 of the trout are more than 35 centimeters long. State assumptions that you make. This wording of this problem is difficult, as probability always is. Realize that it's giving to you this idea of a number of trials. Hey, we're picking out 5 trout. What's the probability that 2 of them are at this or above? It sounds like a binomial distribution, a number of trials, either it's this or it's not. These are all indicators to you that we're actually talking about a binomial distribution. With binomial distributions, we have our number of trials. So like our number of trials is 5. And if we want our probability of success, we need to find, and this is where it gets interesting or difficult, we need to find the probability that a trout is greater than 35 centimeters. So in order to find that, we need to use our normal distribution. So this is both a normal and binomial distribution problem. Because first, in order to find the probability of success, we need to find the probability that x is greater than 35. Which, hey, is equal to 1 minus the probability that it's less than 35. Very IB of this question to build up to the next one. So it's going to be 1 minus the probability that x is less than 35. So we can go ahead and subtract that from 1, and what we get is 0.744. Now, if we're talking about, we want to have at least 2 of the trout to be more than this. Okay, well, our probability of success of being more than that is 0.744. We have a total of 5 trials. We can be 2, 3, 4, or 5 trout that are above that or at the number of, or the length that we want it to be. So we're talking about a cumulative distribution function. So we're going to have a lower bound and an upper bound. Our lower bound is 2. We can have 2. It says at least 2 of the trout. So we can include 2 in this situation, because with binomial, remember the at least, the including versus the not including matters. So 2 fish, and our upper is 5. So we're going to go to binomial distribution, and we're going to do cumulative, which is B. Number of trials is 5. Probability of success is 0.744. Lower bound is 2, and upper bound is 5. So we can get these distributions that all intermingle together, where like we have to use the normal distribution in order to find out a probability of success. And then we can have this idea of like, okay, well, either we have this probability of success or we don't. So it's a binomial question. We end up getting 0.983. So the probability that x exists between 2 and 5 is 0.983. Not a whole lot of space to do that. I'm so sorry for that. When I first typed it up, I thought it wasn't going to be that difficult, and then it was. Okay, next one. Find the probability that a trout caught is longer than 42 centimeters, given that it is longer than 40 centimeters. Given. Conditional probability. Write out your formula. The probability that the length is longer than 42, given that the length is longer than 40. So we've got a certain number of trout that are longer than 40. We've got a handful of them or a bucket full of them. What's the probability that of those trout that are greater than 40 centimeters, that they're greater than 42? So the way that we calculate given or conditional probability, it's in your formula packet. So if you still can't remember this, it's there, it's given to you. The probability of given is at the intersection of these two. So the probability that the length is greater than 42 and the length is greater than 40, all divided by the probability that the length is greater than 40. take a second and think about it logically. To be both greater than 42 and greater than 40 is really just saying greater than 42. Anything that's not greater than 42 but is greater than 40 would be 40 and 41, or like anything in between that and 42. So really the only way that these two guys can agree, longer than 42 or longer than 40, is that if it's longer than 42. So really that's just the probability that your length is greater than 42, divided by the probability that your length is greater than 40. When we have infinite number of trials, which your normal distribution typically does, that it says, hey, you've got a mean and a standard deviation, but it doesn't tell you the number of trials. So when you go into your normal distribution, and it says lower bound and upper bound, there's not like a limit of like 10 that you can go to. So like for greater than 42, our lower bound would be 42. We don't have a limit of like, okay, well, like the greatest number of centimeters that a trout can be would be 100. We don't have that. And so you could do 1 minus the probability that your length is less than 42, very similar to this process up here, that if we wanted to be greater than a certain number, we would do 1 minus the probability that it's less than that number. We could also be just like a little sneaky about it. If you put just a really large number, the largest number you can think of, which is just as many 9s as you can type in. You don't have to do that many, but you have to do a lot. And then put in the rest of your information, your standards. This is why I write it. Your mean is 39. Your standard deviation is 6.1. That is the number that you need. So you could have done 1 minus the probability that it's less than 42, but I'm working smarter and not harder, and I'm going to do it this way instead. I'm going to write down 3.311, and I know that since I'm going to be using it in a division problem later, there we go, that I'm going to have to go back up and scroll and find that exact answer. But I'm going to write this down as a placeholder on my page. I'm going to now find the probability that it's greater than 40. Mean of 39, standard deviation of 6.1. And we get 0.435. Now I'm going to go ahead and divide these out. So I'm going to take this number, enter, divided by this number, enter, and I get 0.716. So you can have things like conditional probability show up when you're talking about normal distribution. All of these things that we've already learned, we're now applying it in, this is the most real world sense that we apply probability. And so the way you first learn probability is this idea of like, you have so many cards and you have so many dice and you're rolling this and what's the probability? It's to introduce you to the idea of this intersection, of the idea of when you add and when you multiply, or to introduce you to the idea of all the probabilities add up to 1. It's kind of your basic introduction. It says determine if the events that these guys are greater are independent. And we know that we have a formula to determine that. We have 2. And one of them deals with conditional probability. So I'm going to say we know that if it's independent, conditional probability is just equal to the first probability. That this probability right here, if it was independent, if they were independent, would just be equal to what this guy is right here. And since it's not, that since this probability of greater than 42 is not equal to the division of these probabilities, that they are not independent. So I'm going to say, since the probability of the length greater than 42, given that the length is greater than 40, does not equal the probability of the length greater than 42, the 2 events are not independent. Okay. That's it. This is your normal distribution. We're not going to get too much more complicated than this with your normal distribution. So hopefully it's making sense. If not, you know what to do. Ask the questions. Good job.